On September 8, 1994, USAir Flight 427, a Boeing 737-300 flying from Chicago to Pittsburgh, crashed into a wooded hillside near Aliquippa, Pennsylvania, killing all 132 people on board in one of the most disturbing and technically complex aviation accidents in U.S. history. The flight had been routine and uneventful for most of its journey, with clear weather and no reported mechanical issues, but as the aircraft began its descent toward Pittsburgh International Airport, it suddenly rolled violently to the left, entered an uncontrolled dive, and slammed into the ground at nearly full speed, leaving no survivors and very little recognizable wreckage. Early investigations struggled to determine the cause, as there was no evidence of explosion, fire, or pilot error in the traditional sense, and cockpit voice recordings revealed the pilots were confused and desperately trying to regain control in the final seconds. After years of exhaustive investigation by the National Transportation Safety Board, the crash was ultimately attributed to a malfunction in the aircraft's rudder control system, specifically a jam in the power control unit that caused the rudder to deflect fully in the opposite direction of the pilot's inputs. This sudden and uncommanded rudder movement forced the aircraft into a roll that was physically impossible for the pilots to counter at low altitude and high speed. The problem was linked to a design flaw involving the dual servo valve inside the rudder PCU, which under certain rare conditions, such as temperature changes or internal wear, could reverse rudder movement without warning. At the time, Boeing and the aviation industry believed the 737's rudder system was fail-safe, but Flight 427 proved that a single hidden failure could override pilot commands entirely. Compounding the tragedy, pilots had not been trained to recognize or respond to this specific failure mode, and even if they had been, the rapid onset and low altitude would likely have made recovery impossible. The investigation into Flight 427 lasted more than 4 years, making it one of the longest and most contentious in aviation history, involving intense debate between Boeing, the FAA, and independent experts, as similar unexplained 737 rudder incidents had occurred before but were not fully understood or resolved. In the aftermath of the crash, the NTSB forced sweeping changes across the aviation industry. Boeing was required to redesign the 737 rudder control system, replace the faulty servo valves, and implement new redundancy safeguards to prevent uncommanded rudder movement. The FAA mandated extensive inspections, retrofits, and new pilot training programs focused on recognizing and responding to rudder anomalies, while also revising certification standards for flight-critical control systems. The crash fundamentally changed how aircraft manufacturers address hidden single-point failures and how regulators evaluate system redundancy and human-machine interaction. For the families of the victims, the loss was devastating and prolonged by years of uncertainty, legal battles, and delayed accountability, but their persistence played a key role in forcing transparency and reform. Today, USAir Flight 427 is remembered not just as a tragic accident, but as a turning point that exposed a dangerous design vulnerability in one of the world's most widely used aircraft, leading to safety improvements that have protected millions of passengers since. The disaster stands as a powerful reminder that aviation safety depends not only on pilot skill and maintenance, but on rigorous system design, honest investigation, and the willingness to confront uncomfortable truths before tragedy strikes.